Here we're doing a question on vectors and regular hexagon merged together. Okay. O is the origin and OPQRST is a regular hexagon. Okay, so if you have this information, you can enter lots and lots of information in the figure. What is that? That first of all, mark the center of the regular hexagon. Okay, that's the center. Now, this is X towards the right. Then this would be X pointing rightwards. And this would be X as well. Okay, and you'll have another X over here. This is because the shape is regular. All sides are equal. All angles are equal. Then you have Y in this direction. So you also have a Y over here. Parallel and equal lines. Okay. Then you also have a Y in this direction. And you also have a Y in this direction. Similarly, you should be able to find this vector. This would be Y plus X. So that means this is also Y plus X because they're parallel and equal. This is also Y plus X. And this is also Y plus X. Now you have enough information to do first few parts of this question. Let's see, go from find the vector QR. So this is just, Q to R. This is QR, which is just Y. Okay. Next is PQ. So that is XY plus X or X plus Y. Next is the position vector of S. Position vector of S means O to S. So this vector, which is going to be Y plus X. So 2Y plus X. Next, it says that the line SR is extended to G so that SR ratio RG is 2:1. Find GQ. Okay, let's enter the ratios first. Says that SR ratio RG is 2:1, which is telling us that SR is double to RQ. So if SR is X and it's double, then RQ should be half X. So enter half X in the figure. Okay, and next we have to find GQ. So we have to go from here to here. So that's minus half Q and then minus Y. So the answer should be minus half Q minus Y. Sorry, minus half X minus Y. Okay. Next is M is the midpoint of OP. Find MG in terms of X and Y in its simplest form. Okay, M is the midpoint of OP. Let's point M. So it should be somewhere over here. So if that's the midpoint, then this should be half X and this should be half X as well. And now we have to find MG. So go from M to G. Okay. If this route is closed, take an alternate route. So I'm going to go from here to M to O. Then I can go from here to here. And then I can go from here to here. That's one possible route. So M to O is minus half X. Then O all the way to R would be 2Y plus 2X. And then R to G is going to be half X. Add all of these up, you should be able to get the answer. Okay, let's do it over here. So we're finding MG. So first I'm doing negative half. x plus 2y plus 2x, and then plus half x. So that's just 2y plus 2x. So mg is 2y plus 2x. Or 2x plus 2y. And lastly, it says H is a point on TQ such that TH ratio HQ is 3:1. Use vectors to show that H lies on MG. Let's enter that in the figure as well. Okay, so you have to show that H lies on MG. So that means it should be somewhere over here. This is what we have to prove, that H is here. Okay, and it says that TH ratio HQ is 3:1. That means this has 3 parts. This will have 1 part. That means the left-hand side is triple the right-hand side. And now you have to prove that H lies on the line MG, which is right here, that H lies on MG. That means we have to somehow prove that the vector MH is a multiple of vector mg. You have to show that the vector mh and mg are somehow multiples of each other. That's how you show two vectors are collinear or 3 points are collinear. You have to basically show that m, h, and g lie on the same line. So you have to show that the vector mh and the vector mg, they are multiples of each other. Okay. Now, we already have mg. We should find mh and show that they're multiples of each other. Okay, how do we find mh? We can go from here to here, then here to, oh, so we can go from here to here, then here, and then here. We need to use the ratios as well. Okay, it says 3:1. So we have, in total, we have 2x on this line from T to Q. That's vector 2x in total. And H is somewhere over here. And the ratios are 3:1. That means this part is 1/4 of 2q, 2x, sorry. 1/4 of 2x, which is half x. And the rest of it is going to be 3/4 of 2x. So that's 3/2x. Okay. So now we know that in TQ, T2H is 3/2 of x. And this is half x. Okay. Now we should be able to find MH. So again, we're going from M to H. So I am going to go from here to here, which is half x. Then up from here to here, which is y plus x. And then back this way, and this would be minus half x. So I'm getting x plus y for MH. And MG, we've already found, that was 2x plus 2y. So we can see that they're multiples of each other. So now you write a concluding statement that if you multiply MH with 2, you get MG. Hence, MHG are collinear points, or hence H lies on MG. That should be your concluding statement.